Should be live. Let me just check.
I want to check.
Yeah, yeah. Something. What the heck?
Oh yeah. Look, we are live.
Okay, is that better?
Yeah, we're good.
Hi everyone, welcome back to Rookie Rescue. Today we're going to be going over intakes and outtakes. My name is Nehul,
I'm Ara.
I'm Marsh.
and today we have a special guest from Astra Machina. So if you want to introduce yourself.
Hey, my name's Quick, and I'm from 1602 Astra Machina from Omaha, Nebraska. We compete in the Nebraska region.
All right. I think today we're gonna we wanted to talk about your robot in 3 days mostly. We saw that was beautiful robot. Do you want to just take us over the robot real quick?
Oh yeah, I guess starting off for a robot, there's like three main parts that make up our robot: the drivetrain, the outtake, and the intake. Starting off with the drivetrain, we went pretty simple with a 435 at a 1-to-1 ratio for our drivetrain for quick movement throughout the match. Then for our intake, we had a dual stage set of Gecko wheels, or not Gecko wheels, I mean boot wheels from GoBuilda. We use these because we found out through testing that these are very good in vectoring the element up our ramp. And lastly, for our outtake, we looked at a few videos from the 2017 game, Steamworks, in which you had to intake the similar balls and shoot them out using a flywheel. So we try to model our shooter after one of the more common flywheels in the 2017 season, and it's worked fairly consistently so far.
So just is the boot wheel, is it on the top or is it on the sides? On the top, I'm assuming.
The boot wheel currently is just spinning on top. We experimented with side spinning too, but we found out that on top is more than well enough to vector the elements inside our robot.
Yeah. So I had some questions after seeing your robot. So I was wondering, one thing is that like how did you come up with your intake geometry and like decide how wide and stuff like that for your intake?
Okay, all right, yeah. So basically, so far when we start off the season, like at kickoff, we started wood, like using some wood prototypes to make some intakes, and we tested different heights in which we could intake the ball at. And once we found like ideal height to pick it up off the ground, we just offset that second stage by the ramp's height, and that allowed us to really quickly intake those balls like from the ground into our intake. Just through a lot of testing and all.
Yeah, just rapid prototyping.
Yeah, rapid prototyping. Using wood was very useful for us. Like last season, we relied more on 3D printing, which kind of delayed our process by a day or two.
Yeah.
But using wood, we were able to quickly prototype very fast.
Did you guys like laser cut the wood?
Yeah, we laser cut the wood. We have an Epilogue laser cutter in our lab.
I think even polycarb is another fast way of prototyping, and I think even some teams like to use cardboard. I know we use some cardboard and just a lot of different COTS parts. Even those work for prototyping, even if you're going for that custom robot.
Yeah, fair. Like we use polycarb once we got our wood prototypes fully solidified. We want to make sure there's a more reliable way to like make sure our mechanisms won't break under practice and use.
We have a question in the chat. Did DB make a robot in 3 days? DB did not make a robot in 3 days. We are currently working on our robot right now.
Yeah.
Yeah. Yeah, and then you want to take us through how you made that shooter geometry as well? Was it also through mass prototyping? And
for the shooter geometry, that more so was making sure we did it right the first time in CAD. Like we spent one good afternoon all the way tonight, basically trying to make sure like we had the correct compression and correct angle to shoot out our balls from, basically. So once we figured out the correct angle and compression we wanted, we ended up designing the shooter It just took I think an hour or two at most to create. And to make sure we made it rigid, we went through Fusion structural analysis tool to make sure that wouldn't break under strain, of course.
Mm-hmm.
And that was about it.
Did you do any calculations to determine like how
Oh
much?
yeah, yeah. At first, when we made our shooter, we thought that one motor was going to be enough, but after some testing, we found out that the spin up time took around 3 seconds, which we thought was probably too long for actual
Mm-hmm.
practical use in a match.
Yeah.
So in our like V1.1, I'd say we switched to having two motors for the outtake. That greatly increased our spin up time as well as our recovery time when shooting balls consecutively.
So how fast is your spin up time now?
Spin up time now for our two motors takes around half a second. We're looking to improve that too by switching to GT2 belts, but for now, it's been working pretty efficiently, I would say.
Mm-hmm.
So, like, obviously, having a robot in 3 days is, like, really quick. So, like, how did you decide what things to prioritize in your design?
Oh yeah, so going into this robot in 3 days, this is my second year in doing this type of competition. So taking notes from last year, one thing we learned really quickly is that it's way better to try and CAD these components like compared to just trying to free build because using free build could get you so far. But we struggled last year, spending multiple hours on end trying to find the correct like components from GoBuilder to like create a robot very rapidly and quickly. But using CAD allowed us to like customize and figure out better ways of like intaking and shooting the elements compared to just using COTS parts.
Yeah. So in your CAD, you you said you used a combination of CAD and prototyping. Was there any other ways you uh went to approach this robot?
I guess some other things we did as well when approaching this robot is like actually getting the CAD of the robot and putting it onto a field. So once we put it onto the field, we figured like take into account the tile sync to figure out how low our ramp should be in perspective of a robot to make sure it wasn't too high or too low to the ground so it wouldn't scratch or not be able to pick up the elements, as well as testing to make sure the angle would be able to shoot the ball from multiple different parts of the launch zones. So
Mm-hmm.
putting it in the field helped us out a lot.
Yeah. And did you choose to look at the parking and then the indexing of the sorting of the artifacts?
Yeah, like earlier on, we tested a few parks on our test chassis. We found that using two sets of slides to push down vertically onto the ground allowed a robot to go underneath. The only issue we found out, however, with that design is that if a robot is approaching 18 inches in width, they won't be able to fit underneath us. So we're
Mm-hmm.
potentially trying to find out another way to better approach the park, potentially by having diagonal parts instead of vertical or perpendicular
Yeah.
parts. We're trying
Yeah.
to think of.
You're just gonna add that onto your existing robot?
Yeah, we hopefully will add. I mean, either we'll add it to our existing robot or we'll add it to our V2 later on this year, hopefully. But for now, I mean, we're going to continue prototyping, hopefully, and figure out better ways of approaching park before we implement it onto our actual design.
Yeah, so for rookie teams out there trying to design a robot and compete when if they have a competition, say in a few weeks, do you have any advice for them?
Yeah, I got one really big piece of advice for those rookies starting off first. It's to test, test, and test. Testing's the best way I think in order
Yep.
to make a robot very fast. Like early on as a rookie, I was always stressed to make sure everything worked the first try. So I thought that testing and failing was a bad thing, but through my 3 years on first, I found that testing and failing is a part of the process, and eventually through all those failures, you'll reach success.
Yeah, I guess I think testing is test so much before you actually design on or decide on building something. Don't rush into building if you don't think it's a solid idea.
Yeah. Like, what are some ways you
Yeah,
guys
agree.
test, like, a prototype? Like,
Oh yeah, so I guess first for really early iterations, we use like common parts you could buy from like Go Build and AndyMark to test really quick, and then we find out that those components don't work or don't complete the task we are trying to achieve. We move on to like laser cutting or 3D printing parts that are better customized to get the job accomplished. Like for example, for shooter, when we try to make shooters out of COTS parts such as AndyMark and Go Build, we had a hard time creating it. So when we switched to using CAD in order to create our shooter, it greatly helped us in making it faster and more reliable. So I'd say making sure first use cut like the parts you have available, and if those don't work, try to make some custom parts and just test with those custom parts or those parts you have available to make sure it works well before making a more solidified design, I would say.
So, like, how much time during your 3 days do you think you spent on like testing and prototyping?
I'd say we spent more time actually testing and prototyping than we did actually building, which is surprising, or at least compared to years prior. We just spent a lot of time like testing to make sure we got it as like, well as we wanted. Like, the goals we want to set aside in the first day of Robot in 3 days, we want to achieve with this robot. And by doing a lot of testing, we were allowed to, I guess, achieve those goals, I would say.
Mm-hmm.
Do you have any advice for like teams?
So I'd say anywhere from like, oh, sorry.
Wait, you can finish.
It took us about a day, I would say, it took us about a day, I would say, of like actual testing itself. And we spent a bit more time testing on the second day. But overall, I would say anywhere from like, if I had to give an hour estimate, anywhere from 8 to 10 hours, I'd say we would spend on testing to make sure all of our components work well.
Yeah. So do you have any advice for any teams that might not have as much access to like custom parts and stuff? Because I know for us, we also have like a CNC, so we have a lot of access. But like for teams that mostly have like COTS parts and like 3D printed stuff.
Oh yeah, I think like what you guys said earlier, using like more cheaper materials such as cardboard, like stuff you could use, like maybe use cardboard and scissors, or try to use parts that you already have available from like previous seasons, unless you're rookies, of course. In that case, try to reach out to local FTC teams in the area too. Most of the time, they'll actually be willing to like help, like let you borrow pieces for the season, and as long as you like learn to properly iterate with those and like learn what you need, you could very quickly order the parts you need eventually. So I say only early on in the season will people or teams usually have issues in like making sure that they could test properly with the correct parts.
Yeah, I think even just like ordering as like quickly, like generic stuff you order from Real Build It, I think you'll always have to test with, and like a lot of that stuff goes out of stock really quickly. So you want to order that and test with stuff you have before in cardboard, and then order that stuff. You can even test with that stuff you order. Um,
Yeah.
did you have like any problems you had while designing the robot?
I guess we did have one issue when we designing the robot. It was earlier on, I believe, when we were in our like we made designs on our whiteboard trying to figure out what was the best design for robot in 3 days. And our
Mhm.
first design we actually agreed upon, we actually had a hard time trying to like to correctly CAD it. So we ended up actually moving on to a different design. So I'd say because the design we had currently we like the design we had on the whiteboard was a bit too complex and we didn't have the correct parts in order to create it. So we knew that we need to go for more simplistic design that allows us to get the robot done both faster and allows us to have more time to like, I guess, work on it and make it better.
What would you change if you had to, or as you progress through the season, what would you change?
I guess viewing our current robot or from a robot in 3 days, which one would you say?
Uh, Probably the robot in 3 days.
Oh yeah, so from the robot in 3 days, one thing we knew to immediately add was a turret because we knew that as defense came along during the game, we need to have some way to defend ourselves or consistently shoot while defense is played on us. And alongside that, the ability to hold three and shoot three balls is what we thought was very important as well. That significantly cut down cycle time. So in those two things we found out, we implemented those to our V1 design and helped us create a more fast and reliable robot when it came in terms of defense and cycle times.
So what changed from your current robot from your robot in 3 days?
So there's I think 3 to 4 main changes. One was the ability to hold three balls more reliably.
Mm-hmm.
Two was the turret, which we added on top. Three was our ability to shoot balls on demand instead of like having our intake run in order to shoot the balls in. We had a servo in the back that now kicks it up whenever we want to, so we don't accidentally fire any balls.
Yeah.
And lastly, for our shooter, we switched from HTD5 belt to dual power chain, which helped decrease the amount of friction we had, which allowed us to get even faster wind up times.
And then what would you change from your current robot going forward?
I guess from those little testing we've done so far, one thing I would say is that, I mean, hopefully adding a park will be in the future, I would say. And something we learned is that we when we made out of wood, parts tended to break relatively quickly. So we recently ordered metal. So making the robot out of metal will help us with durability and all.
Yeah.
So, what are some different designs you tested for your intake, and how did you
For
decide which one to use?
Yeah, for our intake, the first design we actually had was some sort of pivoting intake that pivoted up to go to the human player zone and pivot down to also intake off the ground. But we realized later on that we could just have the human player place balls inside the human player zone on the ground in order to intake. So having the ability to pivot up to the human player zone wasn't exactly needed, we found out. And another design we had was one that consisted of a counter roller. But the counter roller we found out wasn't very like, the balls didn't really need a counter roll to go up the ramp, so we found out that it was not really needed at the end of the day.
And what about for your outtake?
For our outtake, I think our first design was the design we ended up using. Do we just spent a lot of time like looking at different like shooters from different seasons, both in FTC, FRC, and Vex, and we just found out that the Steamworks style shooter seemed to be the best and most reliable for this game at least. So we modeled our shooter after that, designed it, spent a few hours, built it, and it works very, very well for us, I would say.
Yeah, and so going back to that robot, your new robot, something in the chat came up is how will you cut that metal?
Currently we have a CNC in our facility, so we use that to manufacture a lot of our parts. But the only issue is that we're currently experimenting with cutting metal because we usually cut polycarbonate and wood on it.
Yeah.
So for now, we're using FabWorks, a vendor, in order to create our parts for us. But hopefully in the future, we plan to use our CNC to cut the metal plates for us.
Okay, yeah. So you're gonna order it from online for now while you learn how to use the CNC for metal.
Yeah.
Since you're like ordering online, like do you think about like how to like offer like some sort of like customizability or like modularity? Like since it's not like something you can like redo really easily, right?
Oh yeah, I guess for the CAD, that's one of the things I actually focus on too. I forgot to mention earlier, but like having modular subsystems is very useful because, for example, if the intake you design doesn't work when you create in real life, having the ability to just take that subsystem off itself and redesign it is very useful in comparison to taking apart the whole entire robot to work on it again. Like for a turret assembly, it's just 6 screws to take off the entire turret and shooter, which allows us to rapidly prototype on those. Same thing goes for our intake. It only takes, I think, around 6 or 7 like different clamps in order to make sure that we could take off the intake and iterate on it.
Was that like a big design feature you wanted to have?
Yeah, that's one of the things we focused on because last year our V1 was very like robust and built all together, and we had some issues that we couldn't exactly fix by using by without reiterating the whole entire robot. So we learned that like after our V1 and our V2 last year that we need to make more modular subsystems, and that works very well for us. So moving on to this year, we decided that it would probably be smartest to continue on that trend of making modular subsystems.
Yeah. The next question in the chat, what do you think about pass-through intakes in order to like help your partner, like if you wanted to feed your artifact through?
Okay, so I think pass-through intakes, we actually thought of the idea earlier on, like thought it was a pretty good idea, like being able to go to human player's zone and like pass through intakes into your partner.
Yeah.
The only issue we found with that is finding a reliable way to like package a pass through the robot.
Yep.
We experimented with that earlier, but we couldn't really find like a reliable way in order to do that without like potentially messing up our transfer. But if teams could properly design that and make sure it's reliable, consistent, I would 100% go for that. Honestly, it's very good for your alliance partner, and it could also be good for you too if you want to load in a few artifacts in human player zone and then go score a whole bunch once you're done loading.
Yeah, I think definitely making sure that you don't sacrifice your transfer time or your shooting time, but if you can do it well, I
Yeah.
think it's amazing.
So with your shooter turret, like, did you use like a bearing stack or did you use like lazy Susan?
Oh yeah, we actually on Amazon found a Lazy Susan that was the exact specs we needed. So we ended up just ordering that. The only issue is the holes inside the turret didn't have threads, so we had to tap M6 screws into them, which allowed us to mount it and use it for the actual robot.
Yeah. Is there a reason that you didn't use bearing stack or chose
Uh,
the lazy Susan?
the main reason why for us is because we haven't really tested too thoroughly while using a bearing stack. However, we did do a previous prototype using a Lazy Susan, which we found a lot of success in, and we saw other teams use Lazy Susans as well. In the future, we may potentially try to use a bearing stack after like some testing to make sure it worked reliably. But for now, Lazy Susan works very well for us. It did increase our weight a little bit, but we think it was worth it to make sure we had a very simple and reliable
Yeah.
subsystem.
Yeah, I think definitely not sacrificing your speed by looking too much at the micro managing micro packaging. Okay. So next thing, for your intake, was there anything else that you wanted to um build upon throughout the season on your current robot and your robot in 3 days?
I guess one thing we wanted to work on for our intake was like one issue we face currently is intaking from the corner. We want to figure out if there's like some more reliable way in order for us to intake from the corner. Some ways we're potentially trying is like having larger like spinning elements within the center of the center of the drivetrain and intake to make sure we can intake from those corners and reach in very far. And another idea we're thinking of is potentially having some sort of way to like make the intake reach inside or extend out slightly in order to reach those elements instead. Like maybe potentially a drop down or some sort.
Mm-hmm. Like a sort of drop down. Yeah. Okay. Um, what did you think about designing a robot to fit into the 18 by 18?
Oh yeah, we actually have a funny story about this. For our V1, when we first designed a robot, this is before we knew that the extension limits included stretchable, pliable elements.
Mm-hmm.
So when we designed our V1, it was actually 18.5 inches. So we had to make a quick second iteration to make sure it's legal for competition. So now we are sitting at around 15 by 16 inches, I would say.
Yeah.
The only parts we had to cut off really were the like decreasing the length of our intake, which actually helped us out a lot because it allowed us to like drive or I think it made a robot somewhat lighter by having like less material within our drivetrain. So it made us slightly faster by cutting off around like half a pound, I believe.
Yeah, we actually did something similar to that and had to um, shorten our drive base in order to shorten our robot.
Yeah. Does your intake still stick out a little? I don't.
Oh yeah, our intake still sticks out.
Oh,
However, it doesn't stick out fully enough to like be outside the 18 inches. It's like the actual drivetrain's around 15 or 16, then the wheels stick out about an inch or so, I would say.
so what do you think about intakes kind of sticking out further than their drivetrain versus some kind of embedded into their like kind of parallel with the drivetrain?
Yeah, I'd say that from our testing, having like intakes that are parallel to the drivetrain, one issue we found is that you have to like usually push very like drive very far into the artifact in order to intake it, versus having some type of intake that like sticks out. It allows you to like drive over like very loosely and like still be able to intake that artifact very fast.
Mm-hmm.
We also have to sometimes utilize the wall in order to intake certain artifacts and like slam into it potentially, sometimes damaging a robot. Versus having an intake that sticks out, it allows us to easily like reach the artifacts without having to like use the walls like some sort of leverage.
Yeah, I definitely think that having your intake stick out is so much faster than having it anywhere else. What
Yeah.
what did you think about dual intakes and anything like that?
Honestly, I think that's dual intake. Well, like a very cool idea. I think it'll be very hard to like design like efficiently with the 8 motor limit. I believe because most teams having like most likely use 2 motors for the shooter, having another motor potentially for the turret. Very like very much limits the amount of motors you could use within a robot. So making a dual intake robot without like utilizing servos potentially for rotation is
Hmm.
gonna be a very challenging task, I would say.
Did you think about that at all when designing your robot?
I think one of our team members thought of that idea having an intake on the front and the back, but we quickly ruled it out because we believe that using a turret could allow us to shoot from any angle usually, and like we could drive mostly to almost any artifact. And also having a dual intake is pretty hard for a driver once to manage, like driving
Yeah.
both forwards and backwards at different times.
Have you
Um,
looked at? Oh, you want to go?
yeah. So, have you guys considered using like servos for your turret instead of motor?
Oh yeah, it's actually one of the designs we're working on right now. We're potentially trying to switch from one motor for our turret to two Axon Maxes
Yeah.
potentially, because having that extra motor we plan to use for our park, once
Hmm.
we push ourselves off the ground. But for now, if we can't figure out some way to like get rid of the motor on a robot, which most likely will be our turret, we can't really have enough power in order for us to do our level 2.
Yeah.
So for your level 2, are you gonna be using? I'm not sure if I caught this. Are you gonna use one motor or two motor?
We're gonna try to use one like high torque motor and
Uh
have
huh.
another like, passive set of slides on the other side to ensure we have like a stable ascension.
Are you worried about any like that it won't have enough power or anything, or do you think it'll be fine?
We tested basically using like a lot of high torque like motors, such as like 60 RPM, 223 RPM,
Yeah.
113 RPM. We found out that like many of those motors could handle up to 30 pounds like of force. So we realized that it could most likely pick up a robot off the ground when we need it to.
Mm-hmm. So have you on your new robot, have you given sorting any thought?
We looked into indexing earlier on this season, like closer to kickoff, and realized that although we think indexing is very useful, since indexing is only scored at the very end of auto and at the very end of teleop, we realized that we could most likely just have like a normal, like linear way of sorting and like a linear way of like no sorting, and we could just focus and shoot out balls we don't want at the very end, and only focus on like motifs at the last 20 seconds of the match. And for
Mm-hmm.
auto, like most like we ran like different simulations for auto and found out that we only tended to miss out on like 4 to 6 pattern points per auto. So we realized that was a pretty minuscule amount for the complexity needed to add an indexer to a robot.
Yeah.
And what did you think about the ranking points for indexing?
Oh yeah, I think the ranking points for indexing, it will be fairly hard, I will say, to probably earn that ranking point compared to the other two, I would say.
Mm-hmm.
But I think that it's still possible to most likely get those ranking points without an indexer, hopefully. Potentially by either one, like loading in, like trying to shoot purple, it's purely purples into the goal, which alongside that in a perfect motif in teleop would allow you to get that ranking point. So potentially just like brute forcing pure purples usually gets you 6 out of the 9 pattern points, which would be enough for that ranking point. Maybe later on at later competitions when they potentially increase the ranking point threshold, we may have to look in forward to like indexing or other sorting patterns.
Yeah. Do you guys like use a camera, and like what camera do you use, and like
Oh
how do you
yeah,
approach
for
that
our
stuff?
turret, we use a Limelight 3A to auto track our position to make sure like we're always like our turret's always facing the goal, and we potentially will try to add either another camera, hopefully to the bottom of a robot, or use a limelight on a tilt to look down and intake extra artifacts in auto. Because we found out that most likely later on the season, teams will be scoring far more than 12 artifacts in auto, and we'll need to like look on the ground actively to find like artifacts to intake.
Yeah.
Do you have any other like programming like uh I guess helping like any other program that helps your robot, whether it's sensors or cameras?
We are experimenting with adding a color sensor to our intake, which like automatically decides whether or not we like want to shoot it. For example, like if we have a purple, purple, green motif and we have purple, green, purple, it will shoot the initial purple and then potentially like shoot out the green and then shoot the other purple instead, hopefully, so we don't mess up our motifs.
Do you think that's a little do you think that'll like sacrifice your cycle times, or do you think it's worth it to get that motif?
We think that like at the end, the motif is more about the ranking point than we would say is the point, like the amount of points that it scores. Because although like scoring, what is it, 6 points compared to scoring, I think 7 or 8 points with the motif
Mm-hmm.
is less points. The ranking point will matter more because rankings now decided by the average amount of ranking points you achieve per match.
Yeah. The next question in the chat was, what are some potential ways? Yeah. So the next question in the chat is, how would you like work with your alliance, and design your robot to work better with your alliance?
I guess that's actually a pretty challenging a pretty challenging thing to do. I'd say for the most part, maybe like looking online on the FTC Discord and see what a lot of people are doing. Like try to make your robot, like, I guess, in some way help out or like work well with that type of architecture. For example, like if someone like were to like make a very open source like hook design for everybody to use, like climb, for example, on top of another robot, like having that hook design on your robot could potentially make you work well with other robots, like online, for example, that may be in your region or might be more useful in the world championship.
Yeah. Um, did you guys give any thought to that? To any aiding at all for that, while designing your robot?
Sorry, can you say the question again? I had a hard time hearing. My bad. Sorry.
Yeah. Did you give any thought to designing your robot to help your alliance, like, with their cycling and help them in general? Well,
Oh yeah, I mean, one of the things about a robot is that like for our intake, along with intaking fast, it also outtakes very fast. So we could potentially like cycle like artifacts very quickly across the field by shooting it out to our alliance partner, which should hopefully help them score more, like while allowing us to like assist them in any way they need, as well as hopefully later on adding that garage so our partner doesn't have to add any sort of mechanism to the robot and can just simply climb underneath us in order to get that bonus 10 points along with the additional 20 points you get while parking.
yeah. So, going back to that parking, for your parking, is there just going to be a vertical slide or two vertical slides powered by one motor, or was there something else?
Yeah, we'll probably use two vertical slides powered by one motor. Potentially, we might try to figure out some way to mount it diagonally compared to like parallel to each other
Mm-hmm.
because once again what I mentioned earlier with like the 18 inches robot might have a hard time trying to like fit within those like some like parallel slides.
Are you gonna power it with string? Or are you gonna linkage it or something else?
We're thinking we could potentially use like some sort of string or belt system in order
Mm-hmm.
to power our slides. If that may not work or is very unreliable, we could potentially use some type of winch or linkage as well if those don't work.
Yeah.
With like one motor, do you think like the lift would be kind of slow, or like like how much do you think speed matters when trying to park?
I think at the end of the day, there's not much we can really do to like speed up our part or speed up our park potentially. We could try to use some type of PTO system potentially to like power our things instead. The only issue we found out is that without having the ability to latch onto the floor, using like a drive-string PTO will be very hard because of the fact that it's gonna drive around potentially a little bit. It might make you exit outside the parking square, like while
Yeah.
parking.
Yeah. If there are any other questions in the chat, post them now. Otherwise, if you have anything else you want to add on to your robot, and if anything to help any rookie teams, I think, yeah, if you want to add anything.
Yeah, I think one more thing I'd like to give advice to rookies for is make sure even though like you see a lot of robots online like working very well, usually most of those robots are only posted when they are working well and like don't use that as like a comparison, like think that you guys are very behind.
Mm-hmm.
Like you guys have plenty of months depending on the region or weeks at a time in order to design and build your robot. So seeing other robots made very fast shouldn't scare or discourage you from making your own.
Yeah, I totally agree. I think take your time, do it at your own pace, and you'll get there. Yeah. And with that, I think we're ready to end this week's rookie rescue. I don't see anything else in the chat. So signing off. I'm Arav.
I'm Nahol.
And I'm Marsh.
Thank you for attending.
We'll see you guys in 2 weeks.